Young people, welcome back. BMB here for you, taking care of Chapter 7, Lesson 2. Learning objective, students. By the end of this lesson, should be able to divide binomials using the properties of exponents. Secondly, the learning objective for Chapter 7, Lesson 2, simplify expressions containing negative and zero exponents. So, guys, swap back. Students will be able to divide exponents. Bam. So the skill is actually dividing. The concept is exponents. We did the skill of multiplying last lesson. Now we're going to be doing the skill of dividing. And let's knock it out, guys. Boom. Bam. And we're started. Beautiful handout, guys. One column, two columns, looking good. Let's get out of there, get it going. Directions, simplify each expression. Assume that no denominator equals 0. Got it. Can't have a denominator of 0. Number 1, 3, 5, 7, 9, 11 looks like the odds. Number 1, 6 to the 5th divided by 6 to the 4th. All right, guys. 6 5s on top. 6 4s on the bottom. Should I write out all 6? I'm sorry, should I write out all those 6s? I got 5 on top and I got 4 on the bottom. No, we're going to use the rule. The rule is subtract when dividing exponents. So 6 to the 1 power or just 6. Number 2, getting rid of a whole number using the variable now. Same thing. If there's 4 on top and 2 on the bottom, 4 minus 2, x to the 7. Looking good. Number 7 has coefficients. The first one is coefficients, so I guess, I'm sorry, 5. I'm already trying to skip problems. So just one M on top, and then 1, 2, 3. First time I've written it out, guys. 1 on top cancels with 1 on bottom. The invisible 1 stays, but 2 M's left on the bottom. 1 divided by M to the second. Now for number 7, coefficients. So I literally have 12 n to the 5th, 36 n. And it looks like here, guys, that I know how to divide 12 and 36. So I'm going to leave that there. But I still need to do the variables, n to the 5th, and then of course, minus 1, because there's just 1 n on the bottom. And 5 minus 1 is 4, so we got that, but we still need to do our 12 divided by 36, which is literally just 1/3. N to the 4th, 5 minus 1. And guys, I can show it, and when I mean show it, is how I get the 1/3. We went ahead and divided the numerator and the denominator by a common factor of 12. 12 goes in 12 one time, 12 goes in 36 3 times. So, to me, boom, bang, pow, guys. I don't know if I could fit too much more in here. So let's go ahead and get some of this stuff out of here so we can keep going, right? So it's gonna get more challenging, guys, more variables, some negatives, right? But again, guys, we're using an old skill, and hopefully that old skill is dividing and subtracting. So for number 9, a to the 3rd, b to the 5th, divided by a, b to the 2nd. So how many a's on top? Boom! How many on bottom? So that means there's only going to be 1 left on top. So I call this the write-out method. Write out what you see. It has a cubed, b 5th. Well, show me 3 a's in the numerator and 5 a's in the numerator. Show me 1 a in the denominator and 2 b's. This is for those that may not understand what the rule is, guys. Well, I'm showing how the rule works. Cancel. 3 minus 1 will be 2, because 1 on top, 1 on bottom. And of course, 5 minus 2 would be 3. No need to have that 1, just leave it as a squared b to the 3rd. So you don't see me writing the rule, you don't see subtraction of exponent, you just see me writing it out. So for 11, same thing, negative 21, and here it is, right? Negative 3, because right off the rip, I know 7 goes into 21 3 times. Integer rules, negative divided by positive, but W, because 5 minus 4 is 1, and here's where x to the 2nd divided by x to the 5th. Well, you're going to get a negative 3. 2 minus 5 is negative 3. That's why it's in the denominator, guys. say that again. For number 11, if I were to write it out, you would have saw the 3 x's left in the bottom, or if I did the rule, it would have been a -3. You're gonna see that because it's keep coming up, guys. So back to the top, I guess, because here's 2, 4, 6, 8, 10, where I'm gonna take care of the evens now. And again, I could write out 9 12s and 9 8s, but let's just use the rule. And here I'm gonna get a positive because 12 minus 8 is 4. And with the 4, 9 to the 4th power. Number 4, 3 R's on the top, 3 R's on the bottom. Well, guess what? That's the same in the top and bottom. They would cancel each other, right? So watch how I'm gonna break this one down. Let's use the rule. Same base, R. So R to the 3 minus 3. The rule is to subtract. And then T to the 2 minus 4. And guys, guess what? 2 minus 4, I hope isn't an integer issue for you. Okay, take care of it. But I'm showing grouping symbols to make sure we know what to slow down and recognize. R to the 0 power, yes. But T to the 2 minus 4 is a 2, 2 minus 4 is a -2. So that would mean it belongs in the denominator. And let's check this out. R to the 0 power would be 1. I'll point that out in a second. And then of course, T to the 2nd power means it's going to go in the denominator. We call that a negative exponent, right? So let's write this bad boy out. Let's take a real expanded look at it. And what I mean by expanded, guys, is writing it out, right? What do I have? 3 R's in the top. 2 T's in the top. What do I have in the bottom? Well, it looks like we got 3 R's in the bottom and 4 T's in the bottom. And now what will cancel, right? So right here, R cancels with R, will cancel with another R, so there's no R's left. T cancels with those 2 T's. And so you're left with 1 because it cancels out, right? And then 2 T's, or T to the 2nd. So R to the 0 power, you see right there, is the same as 1. And again, that's hopefully something your teacher did. Anything to the 0 power is 1. That's in the textbook. And we just saw it. When they get 0, it becomes 1. So, knocking it out. Number 6, 9 divided by 3. 3. You see that? I did it quick because I knew it. D to the 7th divided by D to the 6th means there's going to be only 1 left in the top. So 3D. For number 8 now. Again, whether you choose to write out 4 W's or to write W to the 4th, X to the 3rd. And in the denominator, W to the 4th, X. Well, all the W's in the numerator are going to cancel with all the W's in the denominator. So 4 minus 4 and X to the 3rd minus 1. So I'll have some more left in the top. W to the 0 power, we see that again. And of course, X squared, well, W to the 0 is 1, so you just left with X squared. Ooh, looks like I'm erasing. It's a lot of erasing. But instead, we need the rule. All right, guys, so as we're getting all that out of there, reminding us the exponent rules for this lesson is to subtract. As we take a look at number 10, I believe we're going to do a good job of recognizing the exponent for each variable. M, numerator, M to the 7th, B to the 2nd, M to the 3rd, B to the 2nd for the denominator. So, breaking it off, a different way of showing it here, you see that I'm breaking it into the M's and the P's. So, M to the 7th minus 3 will give you M to the 4th times P to the 2nd minus 2, all right? Well, that's 1 again. You got it. So, hopefully you're catching on. We got a little mess looking like here. Whoa. I need that. There we go. All right, guys, so we're getting into negative exponents now. And again, if it's a negative exponent, it automatically belongs in the bottom. So I automatically tell myself I need a division line. The reason why I need a division line is because that negative exponent says put me in the bottom and keep my exponent. So I literally am going to box the answer. It's not simplified. Guys, I can do 4 times 4 times 4 times 4 and get a better answer. We're good. Negative exponent again. This time the parentheses has the negative exponent. So again, whatever's in the parentheses belongs in the denominator. My numerator will be 1, but the denominator will be 5 to the 3rd, all to the 2nd power. Because what's in the parentheses is what's being given the exponent. I can do 5 to the third to the second power because 5 times 5 is 25 and 3 times 3 is 9. And now we have what we like to call I believe, a fraction with a fraction, right? So 1 divided by 25/9. That's what that says. Well, hopefully you remember, change it to 1 times the reciprocal, 9/25. So we're going to end up getting 9/25. But guys, you're going to see me move and shake and do that because simplifying your answer is getting it to its simplest form. That's why I said something about 14. Right? But 18, again, I see a negative exponent, but it's already in the denominator. So remember the rule. The rule said if the base is the same, h, then subtract. Well, looks like I'm not going to show that. I'm going to actually write it out. So giving you another example of what to do. We have a whole fraction with a fraction inside of it. So let's move that on over here. And we're going to go ahead and take care of it, meaning it says h to the third divided by 1 divided by h to the 6th. Yeah, that's what it says. So again, guys, let's go ahead and take care of that by knowing what to do. We're going to keep the first, h to the third. And again, I guess I can make that a little better. H to the third over 1, make it a fraction, times h to the 6th over 1. Because when dividing fractions, you got to flip the second fraction, right? So top times top will be h to the 9th, and bottom times bottom will be 1. So the final answer is h to the 9th. See how that whole thing just kind of breaks down to that? It's quite impressive, but it's all about what you best understand. So rewind, take another look at it, but don't worry, it's going to come up again, and it looks like we've got to get rid of this stuff, and that's not fast enough, so I'll talk to you guys. Remember, as soon as you see a negative exponent, your mind automatically goes to denominator. A negative exponent has to go in the bottom. Now, it might end up moving by the end of the problem because you want to simplify, but 100% awareness of a positive exponent, just do what you do. As soon as you see the negative, your brain's automatically thinking, all right, what's different? But we're back on. Oh, we are back on. 20. K to the negative 1 times L to the negative 6 times M to the third. So in this one, guys, I got 2 negative exponents. So my brain says I need to make sure that those go in the denominator. It's only 1 K, but there's 6 L's. L to the 6. But m to the third is still just m to the third, but I want to make it a fraction because the rest of them are fractions, right? So here it is, top times top times top, m to the third. Bottom times bottom times bottom, k, l to the 6th. And guys, that's it. That's it. I can't do nothing else. I know what m is. I know what k and l is, so I'm done. All right? But recognizing again, guys, what's happening with the negative exponent. So when you see a negative exponent, draw your division line. Put a 1 in the top and knock it out. It won't always be a 1 in the top, but you fix that as you simplify the problem, right? So for 22, this one here is quite challenging. What do we say about anything to the 0 power? It is. So all of this to show, guys, that whatever is inside that parentheses, it don't matter. It equals 1. A big old 1. Because anything to the 0 power is 1. I'm not thinking, I'm not going any further. Boom, bang, pow. It's to the 0 power. All right. Plenty of time to reiterate the writing out method. If I see w to the 4th, write w to the 4th. So when you see a 0 exponent, you don't need to write that down. Just know it equals 1. All right. All right, guys. Looks like 24 and 26. 24 can scare your average kid. And why? Well, 15x to the 6th, y to the negative 9th. What do you mean negative 9th? Right? All divided by 5xy to the negative 11th. So I think in this situation, guys, why not we break it down? I can tell you 15 divided by 3. I can tell you if I have 6 x's on top and 1 on the bottom, well, that's 6 minus 1. If I have a negative 9, y to the negative 9, well, the rule says to subtract the denominator. So y to the negative 9 minus a negative 11. So 3 times x to the 5th times y to the, and here it is, guys, negative 9 plus 11, because a negative and negative is a positive. So it actually ended up being 2. So 3x to the 5th y to the 2nd. Now that is not me writing it out, right? Especially when I see the negative exponent, because I know what to do. So let's take a pause, because it says to pause. And I'm pausing right now because I haven't paused yet. We've been going. To me, writing this out is something I make my kids do before we even start doing the rule, because you recognize that all I need to do is subtract. You go, yeah. And then they go, oh, well, why didn't you tell me that? I said, because I wanted you to figure it out yourself. And now that you have figured it out, you got the skill. The skill we're working on involves you subtracting. But if you have an integer and you mess up because that integer is negative, then it could mess up the whole question. So we're gonna get going again, guys. I'm just pointing out again. I'm starting. Pointing out again, guys, that y to the negative 9th is in my numerator. And then, of course, y to the negative 11th is in my denominator. So the rule says to subtract your exponents. So y to the 9th minus y to the negative 9th power minus negative 1. Practice, guys. So here we go. Number 26, more practice, right? So in this practice round, guys, it looks like I don't have any negative exponents, but since there's so much, I think the rule will work best. Start with my coefficients. 48 divided by negative 6, I'm going to leave that to negative. Positive divided by negative. 6 goes in 48 8 times. And then x to the 6 minus 1 power. Y to the, and again the grouping symbols to make sure you don't think it's just 6 minus 1. It's y to the 7 minus 5. Z to the 5 minus 6. And then excuse me guys. What happened to my negative? Yeah, hopefully it'll come back up. But simple math now, guys, except for the z, which isn't a positive 1, it's a negative 1. Now, a rewrite could work out here, guys, where you put that z in the denominator, and here it comes. X, and guys, we know it's negative 8. I don't want to be hearing no game over in the middle of my video, because I'm sure my editor's going to mess with me. But great job, guys. So again, took care of the entire handout. I think we did every single question. I would say this is kind of like 2-step equations with 1 steps, that the more you do it, the less mistakes you'll take, or the less mistakes you'll have. And you can take your time, you don't have to go fast, but this is one of those things that you'll run through when you get there. Guys, thanks for joining me. Can't wait to see you in the next video.